So in this math, we're going to find out the peak discharge in a particular area of 55 hectare catchment. And in this math, we have uh, runoff coefficient for two different, two right, three different zone. That is, one is urban, and one is forest, and another is suburban. So we'll find out C value runoff coefficient as I'll multiply 23 over with 0.45 and 15 with 0.02 on 2 and 17 with 0.32, and I'll divide this with the total catchment area, which is 55 hectare, and from that you will get a C value of 0.3198. So this is runoff coefficient. So then you actually need intensity, and that for 25-year 2 hour peak runoff. And if here you have got the rainfall for 25-year, and this is for 2 hour peak for 2 hour peak runoff. Well, this is not actually for 25, but this is actually for 20 years rainfall, and you got to find out the intensity if the return period is 25-year. So for that, you got to find out x bar, which is mean rainfall for from 1981 to 2000, and you get a value of 32. Is the 32? 32.145 millimeter, and you get standard deviation for sample, that is 5.92, and you have return period said 25-year, and for that you will get x as x bar plus sigma x kt. You got to find out the value of kt. How do you find out? Kt is equals to root 6 minus root 6 over pi 0.577. If I'm not wrong, there's some plus ln. Am I writing it correctly? Hopefully. No, yeah, correctly. Like ln, and you have another ln is actually ln return period over return period minus 1. For return period of 25-year, you get a KT value of 2.405. So you have everything in your hand. You have X bar of 32.145. You have sigma X of 5.92, and you have KT value of 2.405. So from there you can find out the X value, which is 44.25. But this is for 2 hour uh, rainfall, but you got to find it for 1 hour. So for that, you'll divide this with 2 to get intensity. So for intensity, I, you divide x by duration, which is 2. So 44.25 divided by 2, you'll get a value of 22.125 millimeter per hour. So you have rainfall intensity for 25 a return period, and you have a slope of 0.3%, and you have maximum flow length of 825 meter. So you got to check that is your time of concentration is greater than the rainfall duration, and typically it's actually less than time of duration of rainfall. And if TC is less than time of duration of rainfall, then you will get peak runoff from that catchment. So you can find TC value from the equation 0.0195 L to the power 0.77 S to the power minus 0.385. So here you have a length of 0.0195, sorry, 0.860. L is 825 and slope is 0.3%. From there, you will get a time of concentration of 32.14 meters. But your rainfall occurred for 2 hours. So rainfall duration is greater. So peak runoff will occur. So how do you find Q peak? For that, we have a formula that is 0.278 CIA. Here, C is, as we found that out previously, is 0.3198. 0.3198. And intensity was, as you can see, 22.125 millimeter per hour. 22.125, and it should be in millimeter per hour, and it should be in, if I'm not wrong, in square kilometer, and you don't have any unit for C. So you have an area of, as it has been said, 55 hectare. So you will divide 55 by 100 to find these values in hectare to square kilometer, and you get peak discharge in cubic meter cube per second, and the value will be 1.08 cubic. So this is your answer for this math, and this has been done using rational method to find out the cubic, and you did a little bit of statistics to find out intensity for a particular return period. This is all from this lecture.